Hi everybody. We're going to continue talking about what the dot product is good for by talking about projections. So what the dot product allows us to do is answer a question that says, if we have a vector A and we have a vector B, how far does vector B go in the direction of A? Right? There's some part of B that's going towards A, and there's some part of B that's going perpendicular to A. And this is what we're looking for. We're looking for how much of the vector B is going in the direction of A. This is going to be called the projection of B onto A. All right, so that's what we're looking for. We're looking to see how far does this vector B go onto A, in the direction of A. All right, so the thing we're going to do is we're going to calculate to calculate this vector, we're going to calculate how long the vector is, and then the direction of the vector, and that's going to give us what this projection is. All right, so let's draw this picture again. We have the vector A, and we have this vector B, and what we said is this is the projection of B onto A. So this is, we're going to write this, the projection of B onto A. And the reason why we're writing it in this way is because what we're really doing is we could ask this question for any vector B, and we're projecting it onto the vector A. That's why we write it this way. So we ask, what's the length of this vector? Well, we can draw a triangle, right? We have a triangle here, the projection of A onto B, we have the vector B, and we have the angle theta. And because this is a right triangle, then what we know is we know that we can use the properties of a triangle, and we can say the length of the bottom side here divided by the length of B is equal to the adjacent over the hypotenuse, which is equal to cosine of theta. So the projection of A onto B divided by B is equal to cosine of theta. Okay, but we also know something about cosine theta. What did we learn last time? We learned that cosine of theta is equal to the length of A times the length of B times, the length of A. Let's see. Wait, I'm going to go back and I'm going to remember what we did last time in terms of our triangle to remind myself of what this formula is. Remember last time what we did is we said, okay, A dot B was equal to length of A, length of B, cosine theta. And the reason why I'm able to remember this is I'm thinking about that law of cosines that we did. So we have this formula, and what we need to do is solve for cosine of theta. And so cosine of theta is equal to A dot B divided by length of A, length of B. Haha. This is why remembering where the formulas come from is helpful and not just memorizing the formulas. Okay, so cosine of B is equal to this, but we're also getting that it's equal to this. So that means that the length of the projection of B onto A, if we multiply both sides by length of B, we get it's equal to A dot B divided by length of A. All right, so that's the length of the projection. That's how long this blue vector is. Okay, so let's write that in a nice way. So length of B projected onto A is this A dot B over length of A. And the next step is, what's the direction of the projection? So from our picture, we had, this was B, and this is our projection. But we'd like the pure direction of this vector. And probably the best way to remember how to get a pure direction? A pure direction, you get a unit vector. So the pure direction in the direction of the projection, let's say that 5 times fast, the pure direction, the pure vector there, is going to be the unit vector. And to calculate the unit vector, remember we take the length of A and the vector A, and we divide by its length. And so what that means is that if we're going to come up with this vector, this projection, to come up with this projection, then we know its length. This is its length. We know the direction, the pure direction, is A divided by length of A. And so when we multiply this length times the direction, then we get the projection. Right, so this is our formula, and there's so many vectors hanging out here, but it's really just some constant times the vector A. All right, so why don't we do an example? All right, so let's do an example. I'm going to clear all these things and do an example. So let's do an example where we say, I'm going to take the vector 1, 3, and the vector -2, 6. All right, so what do we have here? We have 1, 3, and then -2, 6. And we want to know, so if this is A and this is B, we want to know how far does B go in the direction of A. So if we're just looking at this and we're making a guess, we're going to say, okay, it looks like B goes in the direction of A quite a bit. It probably goes even past A itself. Right, so let me reuse these color schemes, right? So this was A, this is B, and C is this vector. Sorry, the projection is this vector. It's probably going to be a little bit past 1, 3. So to figure out what this vector is, we're going to take A dot B, and that's 1 times -2 is 2, plus 3 times 16, sorry, 3 times 6 is 18, so -2 plus 18, -2 plus 18 is equal to 16, and then the length of A is equal to the square root of 1 plus 9, and that squared is equal to 10. And so what we get is the projection of B onto A is 16/10 of 1, 3. So it's gone more than 100%. 16/10 is bigger than 1. It's gone more than 100% in the direction 1, 3. And so what do we get? We get 16. Well, 16 over 10, let's see, that simplifies to divided by 2. Right, dividing by 2, what we get is 8/5. So we get the vector 8/5, comma, 3 times 8, 24/5. And that's this projection onto the vector 1, 3. All right, so this is a 24, not a 29. So that's it for here. Next video, we're going to talk about the cross product. All right, see you later.